Hi, I'm Johan. I work as a principal engineer in the Akka team. In this video, we will go through the support for MCP, Model Context Protocol, in Akka. Let's start with an overview of what MCP is and what it can be used for. MCP is a client-server protocol for adding capabilities to LLMs, large language models. In general, LLMs cannot interact with the outside world, only answer based on their information they were trained with. MCP clients are either desktop LLM applications or agentic frameworks, discovering capabilities, presenting them to the LLM, and then invoking them or fetching them for the LLM. The protocol runs on top of a pluggable transport, in practice, either standard I/O or HTTP. Since Akka is about building servers and not applications for the desktop, we do support HTTP only. Let's look a bit at the capabilities of an MCP server, what it is that they can provide to an LLM. Tools are LLM lingo for functions that the LLM may ask the agentic framework to invoke. Each tool has a free text description of what it does and a schema for what type of input it accepts and what parts of that input is required. Output of the tools is generally text, which could contain structured data in the form of example JSON. Some tools can also return binary data of different forms. Resources are chunks of text or data identified by a uniform resource identifier. Resource templates is essentially a template for creating a URI for some resource based on a parameter. For example, to get the avatar image of a specific user, it could be a common resource prefix, and then a user ID at the end. Prompt templates accept a few text inputs and return a prompt that it can then be used with LLM for some specific use case. In practice, very few clients support anything else but the tools, so we'll focus on those in this demo. First part of MCP is discovery, where the agent connects to a server and they do a handshake and agree on a version of the protocol they want to speak to each other. The next part is that the client asks the server about a list of available tools. So the server returns each tool that it supports and the description and the input schema for it. The LLM can then decide to ask the agentic framework to call one or more tools provided by the MCP server. Each of those tool calls happens over MCP as well, and then the return text goes back to the LLM. In Akka, MCP support surfaces in two places. The first one is when you define an agent, you can list one or more remote MCP servers that the agent LLM should have access to. On the other side, you can define MCP endpoint components. Much like the existing HTTP and gRPC endpoint components, you define a class that serves some form of protocol. The MCP clients in Akka can, in addition to just list the servers, filter the available tools based on name. For example, if only a specific tool should be allowed and it's known by name in advance. This is of course somewhat brittle, since a remote MCP server could change the method names and descriptions at any point in time. For more advanced control over what the LLM is allowed to call, an interceptor API allows stopping or changing a call to a tool based on the input data, or deny returning or modifying the data returned by the tool before it's handed back to the LLM. When an MCP client in Akka uses an MCP server in Akka, the usual ACLs apply, so it's possible to declaratively say which client's services are allowed to call a specific MCP endpoint. For external MCP request headers is the option. Let's take a look at how this looks in practice. To demonstrate MCP support in Akka, I have prepared two projects: Customer Registry and Customer Service. Customer Service will have an agent, but that agent will need information that is only available from the Customer Registry. Let's start looking at the Customer Registry. The Customer Registry is a normal, non-agentic Akka service. In the service, we have an HTTP endpoint with methods to create and get data about the customer. We also have an MCP endpoint. You can note that there is a specific annotation for MCP endpoints where you define the name of the server, and that we define an ACL that only allows access from other Akka services. So this MCP endpoint will not be available from the public internet. The MCP endpoint can take injected tools from Akka to be able to call other components like entities. It has two methods annotated as tools. The first one is a method that allows you to look up the customer ID from an email. Notice the clear text descriptions for both the tool itself and for the tool parameters. When we get a call, we then use the component client to look up the customer by email in a view. If we find the customer, we return the unique ID of the customer, or if we don't find it, we return a clear text explanation of what went wrong. This is a bit different from, for example, an HTTP endpoint where you would return a 404 or maybe an error if a specific path or resource wasn't found. The other method in the MCP endpoint is a tool to fetch customer details. It takes the customer ID and then looks up the full state of the customer. It turns that state into a JSON string, which it then returns. Again, if the customer couldn't be found, it returns a textual description of the error for the remotely calling LLM. Now, let's take a look at the agentic customer service. The agentic customer service contains an HTTP endpoint with a single method, greet. When it gets a HTTP request for a greeting, it will start a new session for the customer service agent and call it with this method greet, and it passes along the email from the request body. This is the agent class. We define a component ID that is unique for this agent. We extend the agent base class. We define a system message. In this system message, we can see that this agent has the job to be a greeting agent. It will try to greet customers in their preferred language. So remember that an LLM is a stateless thing. It only knows things that it was trained with. So it doesn't know anything about our customers. It will need to use tools to be able to figure out anything about a specific customer. When we specify the agent behavior, we pass on this system message, and then we add one or more MCP tools. In this case, by service name, since the MCP server is another Akka service. We also specify an interceptor. The interceptor will be invoked before the LLM call reaches the provided MCP tool. The only thing the interceptor does here is to provide a bit of logging. Then passes on the request as is. Finally, we have the request-specific message, which contains the email from the request. We then let the agent return the reply as is. In the endpoint, when we get the string back from the agent, we also just return it as is. You may have noticed that there was no specification of which model to use in the code. This is instead defined in application.conf. To make this sample simple, we are using Olama, which is a local LLM runner. We use the Qwen 2.5 model since that is capable of calling tools. Let's start up the customer registry service. So I'm pressing run locally here. We can see that it's spinning up, and it started at port 9001. When you run Akka services locally, they run with an in-memory database. This means that there are no customers in the customer database. We need to set this up to have some customers to start with. I have prepared a small script which will create 2 customers. One that is Johan at Akka.io with Swedish as a preferred language, and one that is Cisco at Akka.io, which has Spanish as preferred language. With this service running, let's now also start the customer service. Now this has also spun up on port 9000. Let's hit the service and see if it works. So we are going to send a GREET request for email cisco@akka.io. As you can see, we got a Spanish response back. Let's also call the greeter with Johan. And you can see now it got a response in Swedish. Let's look at the service logs. You can see that each of the 2 calls to the service led to first a call to figure out the customer ID for a given email, and then another call to fetch the customer details for the customer ID that it resolved. On the MCP service side, we can see the same from the MCP endpoint. Each lookup and the result of them. Let's recap what we just saw. So first, behind the scenes, the customer service agent got a tool listing from the customer registry service. Next, the LLM decided that it needed to use the method to look up a customer ID for the email address cisco@akka.io. And it got back the customer ID too. Then the LLM decided that it needed to use the customer ID to fetch details for that customer. So it got back a chunk of JSON, including the language preference Cisco. The LLM then used this information to craft an actual answer. I hope you enjoyed this and that you are eager to go try this out yourself. Thank you.